Hey everybody, welcome to Deterministic. I'm Brandon Conkle, and this channel is where I explore different ways to embrace more determinism in our programming to make things more predictable day to day. I'm starting off my first live coding stream today, just to give this a try, to see how well this works, to see how the tools work, get more familiar with them, and look at a couple of issues submitted by somebody on the Rust example caster API project, and kind of work through those, talk through what I'm doing. I've got one that I've already tried, and will explain a little bit about why I can't fulfill the request in the issue. And then the other one, I'm going to give it a try on the stream. I've done something similar in a different project, but the project was not quite within the same context. So I'll give it a try and see how it goes. So let me first pull up. Oh, that's not what I meant to do. There we go. Pull up the Rust example caster API project here on GitHub. I am working from an unfamiliar machine. I typically work from a Windows 11 machine with WSL2. And in this case, I'll be working from my Mac machine because it handles the streaming a little bit better because it has a second screen. So when I'm working from my Windows machine, I have just one big ultra wide monitor. And this Mac setup allows me to plug in and use the ultra wide monitor up here, but then also use the Mac monitor itself for the stream here, so that you can actually see what's going on. And it's unfamiliar to me. I haven't developed on Mac probably in a year and a half. No, actually, it's probably been 2 or 3 years. Time flies. Because I switched from Mac to Linux. I still am a big Ubuntu user. On the Linux side, I use that on my primary laptop now. But I was using that as my daily driver for a while. Then I switched to Windows with WSL because I love the WSL virtualization system. It's really been nice to be able to experiment with different distributions without having to format my whole drive or partition it into multiple sections, and do random things like switch the time zone for the entire distribution to test out a bug that I couldn't reproduce in my local time zone. So I had to switch to UTC to see what I was encountering in CI. So things like that. I like WSL for, but I've definitely had a lot of experience developing on Mac, and I've got one of the N1 Macs with the Apple chip that really is screaming fast at compiling Rust. So I definitely am enjoying that aspect of things. So without further ado, let me switch over to the Rust example caster API project. I've got the issues pulled open here, and this issue, I'm going to come back to this one another time. I haven't had a chance to dig into this, but Bradley S. has a great question there, but I'll skip ahead. I've got 2 issues here from Frederick Orrs, and both of them are good questions, good observations, or things that could be improved with the project. This one, though, I gave it a try. Not really thinking it through very thoroughly, just trying to see, okay, what is the type system going to tell me? And it pointed out exactly why this won't exactly work. So let me start off with the issue itself. It says, does it make sense to have an arc for each service in the context if context itself is in an arc? And on the surface, this question totally makes sense. First of all, the context that I'm talking about here is the top level context that for my application. During the init or the bootstrap process of my application, there's a main module that initializes this context that has all the different services. This is essentially my dependency injection container. It has all the services that all of my components in my API will make use of, but it shares that between all of the different GraphQL resolvers or other use cases for the code in my library package. So it putting the context in an arc is helpful for 2 reasons. One, I am sharing ownership between the different services that my API is made up of. So I have a service that covers each domain in the application, which is the business concern that each of my modules manages. And so within each one of those services, I need to make use of some of the internal things you see here, like the database connection or the various services based on traits. So that shared ownership is important so that I don't have to manage lifetimes when I'm passing borrowed instances around. I can instead just use a ref and not have to worry about the lifetime because the arc is using a reference counter to keep track of whether that reference is in use or not and whether it can be cleaned up. So this is one of the big things that's awesome about Rust is that you typically don't need any kind of garbage collection because of the way that it handles ownership and borrowing. It can track right up to the moment a value is no longer needed and clean that up immediately. There's no need for a collection sweep or anything like that. But then there are cases where you can't necessarily clone something directly like that. Or I'm sorry, you can't pass borrowed objects around. You can't pass the references around because you have to manage lifetimes, and managing lifetimes is sometimes really complex, especially when you have to keep track of generic lifetime parameters to your generic types, and that gets down a pretty wild rabbit hole sometimes. So the other alternative is cloning or copying it. And if you have something that is immutable, then that is generally a good way to do things, especially if it's thread safe. But in the case of a lot of the services that I'm working on here, they're not necessarily thread safe because they're dealing with a database connection pool. And so this is a case where an arc really comes in handy because it can set up a thread safe reference counted container for something like my dynamic traits that I'm implementing. So I'll backtrack a little bit more. The reason that I'm using traits here is to make everything really easily testable. I'm kind of borrowing the ideas of dependency injection that I've enjoyed working with in languages like TypeScript or elsewhere, and applying that same kind of strategy here where any one of my dependencies on my services can be easily mocked. And a mock can be injected so that I don't have to create the whole world to test a small unit of functionality. And so this runs across the common criticism of Java where you just wanted a banana, but you get a banana with a gorilla inside the jungle. You've got to establish all that. You've got to create the whole world before you can test anything about the little individual banana. And dependency injection is the way to break free of that and allow you to inject mocked dependencies in. So you still have to have some kind of concept that the outside world is there, but the outside world can be totally fake in this case, using mocks that implement the traits for each of my services here. So his question, though, is interesting because if context itself is in an arc, then why does everything inside the context need to be in an arc? And like I said, I thought that was a great idea at first, so I jumped in and started playing around with it. But it was the type system quickly pointed out the flaw in that approach. And I knew it would. I didn't have to think too much about the concept before I jumped in and started making changes because the type system will lead me through it, and it did in this case. So I have my lib.rs. This is within my folder structure where I'm using cargo workspaces. And the reason I'm using cargo workspaces is to break up entry points from library code. I think library code can be remixed and used among multiple entry points. And if you want to shift something, split it out into its own entry point, maybe merge a couple of different entry points together. If you keep all of the shared code in the libs folder using cargo workspaces, then the entry points can be shuffled around as needed without impacting the libs themselves. The libs are the reusable business logic, and then the entry points just make use of them. So when the entry point, in this case, the API endpoint that's going to be firing up and serving all the GraphQL resolvers, that when it starts up, it initializes this context with all the different dependencies inside it that the services will need to make use of. And you can see I've got them in an arc, but then Frederick was right. In the main.rs, it does establish the context itself in an arc. And so my first thought was, oh, maybe I can just take these outside of an arc and let's see what happens here. So I pulled, first I did the database connection, and this one, it doesn't really care as far as the struct, because this is a solid concrete type. This is not a dynamic trait implementation. But in this case, this is a dynamic trait implementation. And so what it's telling you is that it needs to be sized. So a struct needs to have all of the properties within a struct need to be static, except for, and this inner error message points this out, except for the last field of a struct. So only one field of a struct can be a dynamically sized type. You can use the question mark sized parameter for those cases, but you can only do it for one of the types on a struct. And in this case, we've got several dynamic implementations. So this is telling me I can't just use dyne directly. I need to wrap it in something like a box, or in my case, an arc. So what's the difference between a box and an arc here? A box is intended for single ownership. The reason that something needs to be sized is because it's stored by default on the stack, where primitive Rust types are stored in memory. But when you have something that is not primitive, something that we need to set up a memory structure for, you can put it in a box, and then that will allocate it on the heap instead of the stack. But a box is for single ownership. This is for something that will only live through a single invocation. It's not something that's going to persist after the function is called. A box is something that can be allocated and deallocated when through the lifetime of the function call itself, and not persist beyond that. So you can't really have shared ownership with a box. So the next kind of type that you would think of here, the next container that you would think of, is the arc, or I'm sorry, an RC, a reference counted type. And so the reference counted type gives you shared ownership in a way that's similar to garbage collection, where it will count the references that are in use to the type contained inside. And then when all the references are done, it can then deallocate itself. But an RC is not thread safe. And so in my case, I'm using this with Warp. Warp is a fantastic library for HTTP in Rust using the Tokyo async model. And since Warp spawns a separate thread for each request that it's handling, I need all of my services to be thread safe. So I can't use an RC here. An arc really does make sense. But I was thinking, okay, wait a minute. So in this case, if the context is already in an arc, and I simply need my properties to be sized, then I could use boxes instead and just leave single ownership going, leave the ownership to the context. So I put these in a box instead. And then down here, I'll need to say, okay, box those up instead of arc them up, calling box new on each of these. You'll notice that immediately it starts complaining about things. And this is a good thing. This is one of the great things about Rust. So I'll come down here and I'll see, oh, okay, this other file here, GraphQL, this is what is assembling my GraphQL schema. to execute all of the requests that come in through the HTTP endpoint. And this is also making use of the context and kind of pulling apart different pieces and handing them to different things. So you can see we're handing the different, these are the services, the user service, the profile service, the role grant service, etc. We're setting up data loaders for those, the batch loaders for each of these entities that we might want to load results in batch for. So this is how you get out ahead of the GraphQL N+1 problem. You can use data loader to gather all the IDs of the related objects that you want to fetch along with a top level object. And then with data loader, you're collecting all the IDs and then making one request with all of those at the same time instead of one request per. So I've seen situations where you have hundreds of requests go down to just 2 or 3 with the data loader strategy. So it's handing the services for accessing each of these entities to each of the different loaders for data loader, but then it's also handing it to the async GraphQL context using this data global data accessor strategy that async GraphQL provides. And so not only am I handing users off to the data loader, I'm also handing it off to the schema's context itself. And so that is used inside the resolvers. When I'm actually handling a request, I can then make use of the user service or the profiles or the shows or the episodes or whatever. This is how I gain access to that inside GraphQL resolvers. So already we can see, okay, a box is not going to work well in this scenario because I need shared ownership here. I need to be able to hand this off to different services in different places and have that work not only as shared ownership, but atomically through the atomic reference counted arc that is thread safe in this case. So that is why I can't just take all of the inner properties outside of the box and, or I'm sorry, all the inner properties outside of the arc and make them a box inside the context. Yes, even though the context itself is in an arc, some of the elements inside the context are being spread out and shared internally to other things. And like I was saying, that's all to enable better unit testing with dependency injection so that I can mock all of this stuff internally and not have to worry about the whole world context while I'm doing it. So my next thought was, okay, what if instead of passing each individual dependency in, what if I just passed the whole context in? That way the context could still maintain sole ownership of the properties. They could still be in a box in that case. But then I could just use them from within the context. And so the context could still be in an arc. It could still be shared ownership, shared between all of the things that I need it to. The downside of that approach, though, is that I have to go back to assembling the whole world. You go back to the Java problem of you just wanted a banana, but you got the gorilla and the whole jungle along with it. And so breaking those apart into individual pieces is what makes that easier to unit test, what makes it easier to maintain long-term. Hey, TJW Dev, I just noticed your comment. Yes, we're working on a GraphQL resolver in the Tokyo async model using the async GraphQL library. I have an issue that I'm looking into from Frederick Ors, who asked, why can't we just move everything inside the context out of an arc? And that's why, because I need the shared ownership. I need to be able to pass it around to the different services to make this really easily testable. And since it's inside a warp instance, which is the Tokyo HTTP library, it's a fantastic library. It's a little bit hard to work with for people who've not used a functional pattern before, but it's really extremely performant. But it spawns multiple threads to handle each request. And so this needs to be thread safe also. So that's where the arc comes in, and that's why everything needs to continue to be in an arc in order to maintain the really flexible testability that I've got here. So I will go ahead and close this issue out and link to the recording of this video to explain everything. The other thing that I wanted to look into was from the same uh, user submitted a request about the update function. And this is used in several entities, not just the one pointed out here, but the update function is basically handling the update GraphQL mutation, where we're saying take an existing record and update it with new properties. And in the JavaScript world, I'm really familiar with using null and undefined distinctively, separately. So for an update function that's a partial update, a patch essentially, that can take some properties to be updated and leave other properties unchanged, I would use undefined and null to differentiate between that. So if you wanted to leave a property unchanged, you would pass undefined. If you wanted to set a property to empty, you would pass null. And if you wanted to set a property to something, you would just pass a populated property, an actual value. But in the case of Rust, I haven't found an easy way, and maybe there is, but I just haven't encountered an easy way to distinguish between undefined and null. So in other projects, to approach the problem that he's talking about here, I've used a double option, essentially. So the problem that he's bringing up here is that you cannot use the update GraphQL operation to set an optional property back to none. Since I'm using the if let sum here on an option, you can only pass some values, and anything that you pass as none will be left unchanged. So you can't set an optional value to none in this scenario. So what I've done, like I said on other projects, is to use a double option. So I'm going to, this is totally live on the fly. I haven't tried this yet in this project, in this context with GraphQL, but I'll give it a shot. So we have the shows. I'm in my libs domains shows folder here, and I'm going to pull open the model. Or no, actually, I need to pull up the mutation. So this is my GraphQL input types that I've set up. I also have queries here for the query types, but my mutations.rs has my input types for mutations, and I have my update show input here. And with other projects, I've just done an option. But I'm going to have to remember how I actually passed that in the HTTP request. So right off the bat there, that's what it looks like in my other project. I'm pulling up the source code for my other project right now to see then how am I actually making use of that, because I can't remember. And I probably should have reviewed that before I started the stream, but this was kind of on the fly. Let's see. Yep, I'm definitely not making for some engaging viewing here. I'll have to figure out exactly what I was doing with that before. But all right, let me try to think through how this was working in the other project. I'll bet it was differentiating an undefined and a null somehow. Yeah, I'm realizing I started down this path without having a clear direction because I can't remember how the option worked in the other project. So I'll probably have to go ahead and abandon this for the stream today, but go ahead and give it some work on it tomorrow and really identify how the heck is this actually supposed to work. All right. Well, I think I've covered enough for a first example stream. This is the first time I've tried the live stream function. I'm trying out a tool called StreamYard that's pretty great for managing streams like this. I'll be inviting guests and things like that. Hopefully this has been interesting, and you can laugh at my lack of preparation for this second part of the question here. I thought it would be more obvious, but then when I started typing it, I realized, wait a minute, how do you translate that to HTML or HTTP in any case, I'm going to go ahead and shut it down now, but thank you for watching. I'll be back maybe later this week with another stream. Definitely be back next week with a new episode of the Rest Review, where I will be inviting my first co-host, Alex Galeris. So thank you, everybody, for watching, and I'll see you later.